Hey everyone, my name is Brian Trong, and today we're going to be talking about gRPC. So gRPC is a modern communication framework that was introduced in 2015 and is governed by the Cloud Native Computing Foundation. And today I'm just going to introduce the concept with a simple example, and hopefully that will outline some of the benefits that it could bring to your application. So let's say we have an application and we have a front end. And I'm going to signify this with a little computer monitor. And the majority of the talk today will be about the backend layer. So let's say in our example, we have a backend microservices layer of Python. So let's say Python handles something like analytics. It doesn't really matter, but Python is one microservice. And let's say we have another in Java and one in Golang, for example. And what I'm going to do is I'm going to go ahead and draw arrows between them to signify that these microservices need to connect and communicate with each other. I do want to stop here and point out that I am specifically talking about communication between microservices, and I'm not talking about communication between the front end and the back end, because communication via gRPC does not natively work out of the box with web browsers. So in particular, gRPC is more oriented for this type of communication. So the first talking point that I want to mention with gRPC is that it brings about significant improvements in convenience and scalability. So I'll just write convenience here. And if we were to not use gRPC, it would be important to note that Python has its own HTTP client libraries, Java has its own, Golang has its own, and these are client libraries that are supported by different groups. And if we were to extend them, it would be different individuals that are working to maintain these client libraries, and it could get out of hand, especially as we add more microservices that could be of different runtimes in different languages. Now, gRPC handles all of the implementation to the HTTP protocol for us. So as a developer, we don't have to worry about that level of detail, since gRPC implements the connections with HTTP 2.0 for us. So that's something that we don't have to worry about moving forward. Now, on top of that, hand in hand with convenience is gRPC offers code generation. Now, you're probably wondering, how does code generation work? How does it know what code to generate and whatnot? And the answer lies in protocol buffers. And if you're not familiar with protocol buffers, you can essentially think of them as a form of a contract for communication. So traditionally, with an API, you don't necessarily have a API contract that is defined by the protocol itself. So if we're using REST, for example, you're just sending JSON messages, with key value pairs that aren't checked until you get to the receiving end, and that's where it handles it. But with these protocol buffers in the protofile, which is where you define what is essentially a schema for the data that is being sent, you can define things like the fields that you expect, which fields are required, which fields are optional, as well as the object types for these fields. On top of that, in the protofile for the protocol buffer, you also define the procedures that you expect to expose. And these are essentially defining which procedures. So RPC standing for remote procedure calls. You're essentially defining which procedures are callable remotely from other microservices. And what happens is, if you want to have the code generated, you run the protofile against a compiler. And what is output is source code in your respective language. So for example, if this was Java and you defined in your protofile that you're expecting messages to have 3 fields of type int, string, etc., what is output is essentially an interface that allows you to create that creates the classes for you, that implements the object types that you outlined in your protofile. Now, the next point I want to talk about is performance. And we already touched a bit about performance, with HTTP 2.0 being a much more modern protocol than HTTP 1.1 that already delivers a significant number of improvements, but performance is further delivered with protocol buffers, as protocol buffers are serialized and sent as binaries across the wire. So if you're familiar with JSON, which I think is the de facto message type that is sent via REST API these days, you're probably well aware that JSON messages are not compressed or flat by any means, considering that they are key value pairs that certainly are not the most space efficient. With these protocol buffers, these messages are sent as binaries, which are significantly smaller than the normal JSON message. Of course, that begs the question, what about using something like gzip to compress the JSON message before transmission? And that kind of brings us back to convenience, in that if we were to use something like gzip or a tool to compress these JSON messages before being sent, you would need to import gzip or whatever compression tool you're using on each of the microservices, and that would be a bit of a pain over time, since you're basically working on different microservices and you're implementing that yourself, whereas with gRPC, this is all handled for you. So to summarize, gRPC offers convenience in the form of code generation, protocol buffers, the client library being implemented for you, and on top of that, performance overall using HTTP 2.0 and sending very small performant messages across the wire. So hopefully this provided an example of gRPC in a useful, applicable format. Of course, gRPC is not the Band-Aid cure-all solution for communication, but I did want to emphasize that this can be a good solution for your application. Here are some videos that may be of interest to you. If you have any questions about this video, add them in the comments below and be sure to like and subscribe. Thanks.